Bismillah ar-Rahman ar-Rahim. Assalamu alaikum students. This is Hamza Noor from Aero Education Network. And in this particular video, I'm going to solve some questions from CIEP1 A-Level Maths. The topic is circular measure. And this is handout question number 4, which is October-November 2007, paper 1, question number 7. And the question says that in the diagram, AB is an arc of a circle with center O and radius r centimeter and angle AOB is theta radians. The point X lies on OB and AX is perpendicular to OB. As you can see that over here, show that the area A centimeter square of the shaded region AXB is given by this formula. Area is equals to half R square completely multiplied by theta minus sine theta times cos theta. And this part is worth 3 marks. Okay, so what we can say that in order to find the area of the shaded region, first of all, if we find the area of the sector AOB and then we subtract the area of the triangle AOX, so we would be able to find the area of the shaded region over here. So I can say that in order to find the area of the shaded region, the area of shaded region, it would be equals to area of sector AOB, and then you subtract the area of triangle AOX. All right. So in order to find the area of the sector AOB, R is unknown, theta is unknown, and we need to give our answer in terms of R and theta. So this will be simply half R square theta. Okay, so here we have the formula for area of the sector, half R square theta. Whereas in order to find the area of the triangle AOX, what you can do over here is that you need to express this in terms of sine theta and cos theta. Okay, so in order to find the area of this triangle AOX, this OX length will be the base, okay, and this AX length will be the height of the triangle. Because we need to give our answer specifically in terms of sine theta and cos theta, so we need to involve sine theta and cos theta over here. Okay, so in order to find the area of the triangle AOX, we can say that half multiplied by OX multiplied by AX, meaning half into base into height. Okay, so half multiplied by OX multiplied by AX. This would be the formula for the area of triangle AOX over here. Okay, makes sense. So first of all, we are going to find the length OX and the length AX in terms of R and theta. So if we consider this triangle AOX, okay, if we consider this triangle AOX, we can see that this angle is theta, okay, and the hypotenuse is R. The length OA is the hypotenuse. And if we want to find this OX length, so OX is basically adjacent side, and we can involve this hypotenuse over here. So I can say that cos theta is equals to adjacent over hypotenuse, which is OX divided by R. So therefore I can say that OX is basically, so therefore I can say that OX is equals to R multiplied by cos theta. As simple as that. The length OX is R multiplied by cos theta in terms of R and theta, where R and theta are unknown right now. And in the same way, what we can do, we can find an expression for AX length as well. And for that purpose, this opposite side would be involved. So I can say that sine theta is equals to opposite over hypotenuse, meaning AX divided by R. So therefore, we can say that AX is R multiplied by sine theta. As simple as that. AX length is R multiplied by sine theta in terms of R and theta, where R and theta are unknown right now. So therefore, I can say that the area of triangle would be half multiplied by R cos theta multiplied by R sine theta. And here you have the area of sector, which was half R square theta. So here we can say that taking half R square as common, multiplied by theta minus cos theta times sine theta. But what we need a specific form. Okay, so in place of cos theta times sine theta, I'm going to write sine theta times cos theta, which is exactly the same thing. So therefore, we can say that taking half r square as common, multiplied by theta minus sine theta times cos theta. Here we have shown as per the requirement of part 1. Okay, this is the expression for the area of the shaded region, the formula for finding the area of the shaded region over here. In part 2, it says that in the case where r is equals to 12 and theta is equals to pi over 6, find the perimeter of the shaded region AXB, leaving our answer in terms of root 3 and pi. Okay, so we need to find the perimeter of the shaded region over here. So in order to find the perimeter of the shaded region over here, first we have to find this length XB. Then we have this length AX, which is the height of the triangle. Okay, and then we will add this arc length AB over here. Okay, so I can say that in order to find the perimeter of the shaded region, we have a formula: perimeter of shaded region will be equals to arc length AB plus XB length and plus AX length. All right. So now in order to find the arc length AB is basically R multiplied by theta. Okay. The formula for finding the arc length for the sector. So R is basically 12 and theta is pi over 6. So arc AB would be 12 multiplied by pi over 6, which is 2 pi centimeter. Okay. And then we will find the length XB. Okay, so in order to find this length XB, what we can do over here is that from OB, we can subtract this length OX. I can say that in order to find the length XB, from OB, I can subtract OX. As simple as that. Okay, so that we would be able to find the XB length in terms of R and theta first. Okay, so as we can see that this OB is also the radius of the sector. In the same way, OA is the radius of the sector. So when OA is R centimeter, so OB is also supposed to be R centimeter. So OB is basically R. And then what we are going to do, we are going to subtract this length OX. And we have already found this thing in part 1 that OX is R multiplied by cos theta. So in this case, in part 2, R is specifically 12 and theta is pi over 6. So I can say that the length XB is supposed to be 12 minus 12 cos pi over 6. So 12 minus 12 cos pi over 6. This is supposed to be, in an exact form, this is 12 minus 6 root 3. XB length is 12 minus 6 root 3 centimeter in an exact form. Okay. And now we are supposed to find the length AX, and AX, the expression for AX is R multiplied by sine theta. For AX, we have expression R multiplied by sine theta. So in this case, R is 12 and theta is pi over 6. So 12 multiplied by sine pi over 6. So sine pi over 6 is basically half, and into 12, this will be 6 centimeter. Okay. So here we have the length AX as well. And now what we are going to do? We are going to find the perimeter of the shaded region. And for that purpose, we have already made this formula over here. Arc AB plus XB plus AX. Okay. So here we are going to just find the perimeter. The screen is hanging because of internet issue. Okay, so arc AB is basically 2 pi centimeter. Okay, so therefore I can say that the perimeter would be 2 pi plus the XB length, which is 12 minus 6 root 3, and then plus AX length, which is 6 centimeter. Okay, so therefore I can say that 18 minus 6 root 3 plus 2 pi. This is basically the exact form of the perimeter of the shaded region. And as per the requirement, we have expressed our answer in terms of root 3 and pi. So the perimeter of the shaded region is supposed to be 18 minus 6 root 3 plus 2 pi centimeter. Okay, so this was basically handout question number 4, which is October-November 2007, paper 1, question number 7. All right, so now the next question is handout question number 5, which is May-June 2008, paper 1, question number 5. It says that the diagram shows a circle with center O and radius 5 centimeter. The point P lies on the circle. PT is a tangent to the circle and PT length is given to us, which is 12 centimeter. And the line OT cuts the circle at the point Q. Okay, so the requirement of part 1 is to find the perimeter of the shaded region, and this part is worth 4 marks. All right, so now what we need to do, we need to find the perimeter of the shaded region over here. And for that purpose, first of all, we will have this length PT, and then we will have this length QT and this arc length PQ. Okay, so that we will have the perimeter of the shaded region over here. So first of all, I'm going to find this length QT, and for that purpose, I'm going to consider this triangle OPT, or you can say POT, same thing, POT, where OP length is 5 centimeter and PT length is also given to us in the question. And since we know the fact that angle between the tangent and the radius is always 90 degrees, okay, so OT would be the hypotenuse. So first of all, I'm going to find this OT length. Okay, so OT square is equals to PT square plus OP square. Okay, so OT square is 144 plus 25, this is 169, and the length of OT will be 13 centimeter. OT will be under root of 169, which is 13 centimeter. All right. So here we have the length of OT. And since OP is the radius of the sector, OQ is also the radius. Okay. So OQ is also 5 centimeter. So in order to find this QT, what we have is 13 minus 5. So therefore we can say that QT length is OT minus OQ, which is supposed to be 13 minus 5, which is 8 centimeter. Here we have the length of QT. Okay. So now what we are going to do, we are going to find this arc length PQ. And for that purpose, we need this angle theta over here. Okay. So I can say that arc length PQ, arc length PQ is R multiplied by theta. As we know the radius of the circle, but we don't know this angle theta. Okay, we don't know this angle theta over here. So what we are going to do, first of all, we are going to find this angle theta. So opposite over hypotenuse, or we can say adjacent over hypotenuse, or we can use opposite over adjacent, whatever you feel. Okay, so cos theta, I am using cos theta. So cos theta is equals to adjacent over hypotenuse, meaning OP divided by OT. And OT we have already found, which is 13 centimeter. So I can say that cos theta, cos theta is equals to opposite side was 5 and hypotenuse was 13. So angle theta is cos inverse 5 over 13. So theta is cos inverse 5 over 13. All right. So how much is this angle? Cos inverse 5 over 13. Okay, and this angle is 1.1760 radians. Theta is 1.1760 radians. Okay, so now what we are going to do, we are going to find the arc length PQ. So arc PQ is supposed to be R multiplied by theta, meaning 5 multiplied by 1.1760. So 5 multiplied by 1.1760, this is supposed to be 5.88. Arc length PQ is 5.88 centimeter over here. Okay. And then we need to find the perimeter of the shaded region. So I can say that the formula for the perimeter of the shaded region is supposed to be the perimeter of shaded region is supposed to be arc length PQ plus the length QT and plus the length PT. Okay, so arc PQ is 5.88 centimeter, and the length QT is 8 centimeter, and the length PT is given to us 12 centimeter. So 5.88 plus 8 plus 12, this is supposed to be 25.88 centimeter. And correct to three significant figures, our answer will be 25.9 centimeter. So as we know that the values which are non-exact, they are supposed to be given correct to three significant figures unless otherwise stated another accuracy of measure in the question. So here was the answer of part one. The perimeter of the shaded region is 25.9 centimeter. Then in part two, we need to find the area of the shaded region. So in order to find the area of the shaded region, first of all, we are going to find the area of this triangle POT. And from that, we are going to subtract this area of sector POQ. Okay, so in order to find the area of shaded region, in order to find the area of shaded region, first of all, we will find the area of triangle POT, and then we are going to subtract the sector, area of sector POQ. Okay, so in order to find the area of triangle POT, simply what you can do is half into base into height. Okay, so half into base into height, meaning half into PT length into OP length. Okay, so this will give you the area of triangle POT, and whereas the area of the sector is half multiplied by r square multiplied by theta. Okay, so half multiplied by OP square into what? The angle theta is POQ. All right, so here we are just going to use the formula over here. So half into base into height, the length of PT is given to us and OP is also given to us. PT is 12 and OP is 5. So half multiplied by 12 multiplied by 5. And then we will subtract the area of the sector, which is half multiplied by 5 square multiplied by theta. And theta was 1.1760 radians. Okay, so 12 times 5 divided by 2, this is 30. So 30, and then you will subtract the area of sector. So area of sector is 5 square multiplied by 1.1760, 1.1760, and then divide by 2. So this is 14.7. Okay. So 30 minus 14.7 centimeter square, 15.3 centimeter square, correct to three significant figures. Here is the area of the shaded region. As simple as that. So here was the solution of handout question number 5, May June 2008, paper 1, question number 5. All right, so now let's move on to the next question, which is question number 6, October November 2008, paper 1, question number 6. It says that in the diagram, circle C has center O and radius 5 centimeter. The points P and Q lie on the circle, and the arc length PQ is 9 centimeter. And then it says that the tangents to the circle at point P and Q meet at the point T, and the requirement of part one is to calculate this angle POQ in radians. Okay, we need to find this angle POQ over here. And since we know the fact that the radius is 5 and the arc length is also given to us, so simply we can use the formula of arc length. So PQ, arc PQ will be equals to R multiplied by theta. So arc PQ is given to us and the radius is 5 centimeter. So theta is equals to 9 over 5. So theta is equals to 1.8 radians. All right. As simple as that, this was the answer of part 1. Then we need to find the length PT. Okay, so now I'm going to consider this triangle POT over here. Okay, so first of all, I'm going to connect these points O and T with each other. And since we are studying a concept since O level and IGCSE mathematics, that at the point where the two tangents meet at any point outside the circle. So if we connect the line from point T to O, okay, so this whole shape POQT will be distributed in two equal halves. Okay, and therefore we are going to say that this angle POT is exactly equal to the angle QOT. This OP length is equal to OQ length. This PT length is equal to the QT length. And here we have established fact that this triangle POT and this triangle QOT, they are congruent to each other. So here we are going to say that this angle POT is equal to the angle QOT, which is equals to theta over 2, meaning 1.8 divided by 2. So this angle POT is supposed to be zero point 0.9 radians. As simple as that. So now what we are going to consider this triangle POT, where this angle is zero point 0.9 radians. Okay. And the opposite side we need to find, which is PT, and OP is given to us. So we can use opposite over adjacent. So therefore, we are going to say that tan theta is equals to opposite over adjacent, meaning PT divided by OP length. Okay. So therefore, I'm going to continue the working over here. So therefore, we are going to say that tan 0.9 is equals to PT divided by 5. So therefore, we are going to say that PT is equals to tan 0.9 is completely multiplied by 5. So 5 multiplied by 10.9. This is supposed to be how much? 5, 10.9. This is 6.30079. So 6.301 centimeter. Okay, so therefore correct to three significant figures, 6.30 centimeter. All right. This was the requirement of part 2, the length of PT. So now we need to find the area of the shaded region in part 3. So in order to find the area of the shaded region, first of all, we are going to find the area of this four-sided figure POQT, and then we are going to subtract the area of the sector POQ. Okay. So in order to find the area of shaded region, first of all, we are going to find the area of this four-sided figure POQT, and then we will subtract the area of sector POQ. Okay, now in order to find the area of this four-sided figure POQT, as I've explained that these two triangles POT and QOT are exactly congruent to each other. So in order to find the area of this four-sided figure POQT, what we are going to do, we are going to add the areas of two triangles. Okay, so area of POQT is exactly the same thing as saying 2 multiplied by the area of triangle. Now, area of the triangle POT is supposed to be half into base into height, meaning half multiplied by PT multiplied by OP. As simple as that. Half multiplied by PT multiplied by OP. This will be the area of the triangle, and this will be multiplied by 2 in order to get the area of the triangle POQT. And then we are going to subtract the area of sector. So area of sector is supposed to be half multiplied by R square multiplied by theta. So the radius is OP. So half multiplied by OP square multiplied by the angle POQ, which we have found in part 1. Okay, so 2 times the area of triangle POT. So 2 times half into base into height, meaning half into the length of PT was 6.301 centimeter. As I'm going to use this value in my further calculation, the length of PT, so I'm going to take the value which is correct to 4 significant figures. Okay, so in order to avoid any premature approximation, for the safe side, PT will be taken as 6.301 multiplied by OP length, which is 5. Okay, and then we are going to subtract the area of the sector. So half multiplied by 5 square into what? The angle POQ, which was 1.8 radians. Okay, so this 2 and 2 is cancelled out. So 6.301 multiplied by 5. This will be 31.505 centimeter square. So 31.505. And then we will subtract the area of the sector, which will be 5 square multiplied by 1.8 and then divided by 2, meaning 22.5 centimeter square will be subtracted. So 31.505 minus 22.5, this will give us 9.005. 9.005 centimeter square, but correct to three significant figures, 9.01. 9.01 centimeter square will be your answer. Okay, correct to three significant figures. And as per the marking scheme, we can see that any value in this particular interval is acceptable for this answer. Okay, because they have taken the length PT as 6.30, I've taken the value which is correct to four significant figures for PT in the further calculation. Okay, to avoid any premature approximation, so that is also fine. So this value is acceptable as per the answer of the marking scheme. Okay, so this was the question number 6 of the handout.